Hello, today we are going to go over section 5.3, which is solving systems of linear equations by elimination. Here are the steps for solving systems of linear equations by elimination. I took this and copied and pasted it from your book. So please keep this handy as you are going through the notes and as you are doing your problems. If you need to, you can always go back to Big Ideas and watch the videos and examples there, or you can go to Khan Academy and watch the videos there as well. So here is our first example. We have two equations. The first equation is x plus 3y equals negative 2, and x minus 3y equals 16. We very well could try to solve this by graphing or by substitution. But you're going to learn a third way using elimination. And I want you to all be comfortable using graphing, substitution, and elimination. So when looking at a problem, you know which one is the best one. So here, the first step is multiply, if necessary, one or both of the equations. So if we look at this equation, these equations, you have two options. If you notice here, I have an x and an x. And here I have a positive 3y and a negative 3y. Right now, I want to solve by adding because it's much easier than subtraction. So what we want to do is we want to look for our variables, and we want to have one variable that's positive and one variable that's negative. And if we look, we have a positive 3y and a negative 3y. So if we were to add these two equations together, so I'm going to put a plus sign, I'm just going to write an equal sign underneath. If I were to add these, a positive 3y and a negative 3y cancel to give us 0y. So I don't need that anymore. So what do I get when I add x plus x? I get 2x. My y's canceled. I'm going to carry down my equal sign. And what is a negative 2 plus 16? You get 14. So now I have a nice equation that I can solve for. I'm going to solve for x, and I am going to divide by 2. So cancel, and I'm left with x equals 7. So of course, when we're solving equations, we need an x and a y variable because we have a system. We're finding the intersection point. So what I need to do is I need to take one of my beginning equations, either the top or the bottom, and plug my x into. Since the top one looks a little nicer to me, I'm going to use that one. So I have x plus 3y equals negative 2. So I'm going to take that 7 and plug it in for x. So 7 plus 3y equals negative 2. Subtract 7. I get 3y equals negative 9. Divide by 3. And I get y equals negative 3. So if I take that and plug it back in, it will give me the correct answer. So again, you need to check those to make sure they are correct. Equals 21. Oops. All right. Here's our second equation in our notes. So again, we are looking for either our x's or y's where they have the same coefficient. One's positive, one's negative, so that they cancel out. So looking here, I have a negative y and a positive y. So if I add those, a negative y and a positive y will cancel out. So 2x plus 4x equals 6x. 9 plus 21 equals 30. So again, I can divide by 6. and I get x equals 5. So I'm looking for the intersection point. So I need to find the y value, and I'm going to plug it back into one of my equations. Now for me, the bottom one doesn't have any negatives, so I'm going to work with that one. 4x plus y, about that, 4x plus y equals 21. So I'm going to plug that 5 in for x. You get 4 times 5 plus y equals 21. 20 plus y equals 21. Subtract that 20. You get y equals 1. So I found my intersection of 5, 1. Now considering I've already done these, I've already checked them, and it does work for the top and bottom equation. So let's look at this example right here. If you notice, I have a negative 5x and a positive 5x. So if I add these, the negative 5x and 5x will cancel. So 2y plus y equals 3y. 13 plus a negative 1 is 12. So I want to solve for y. Divide by 3. And I get y equals 4. Again, I'm looking for the intersection point. So I need to find the x value. Again, they have to work in both of the equations. This bottom equation looks a little nicer, so I'm going to use that one. You could use the top one. So I get 5x plus y equals negative 1. Take that 4 and plug it in for y. We get 5x plus 4 equals negative 1. Subtract 4. I get 5x equals negative 5. Divide by 5. X equals negative 1. Again, you need to check it in both the top and bottom equation. Last but not least, I have this equation, these two equations right here. 3x plus 4y equals negative 6. 7x plus 4y equals negative 14. Now, if you notice, I have a positive and a positive. So if I add those together, they will not cancel. But what you can do is you can subtract these two equations. So what is a 4y minus 4y? It gives you 0. So these will cancel if I use subtraction. So looking at the first, 3x minus 7x is a negative 4x. Equals, and then I get a negative 6 minus a negative 14. So keep change, and I'm left with, 8. So if I want to solve for x, I need to divide by a negative 4. And I get x equals negative 2. So if I would like to solve for the intersection point, I need to plug that negative 2 back into one of my equations and solve for y. I'm going to pick the first equation because it's got smaller numbers. So 3x plus 4y equals negative 6. Take that negative 2 and plug it in. So 3 times negative 2 plus 4y equals negative 6. Negative 6 plus 4y equals negative 6. Add 6 to both sides, and I get 4y equals 0. Divide by 4, and I get y equals 0. So my intersection point is negative 2, 0. You want to take that, plug it back into your two equations to make sure they are correct.